let's call this one red.py. I'll post these examples up on the website. Def apply to each of function and values. Okay. Result is the empty list. For each value in that original list, result temp equals func of v, result.append temp, return result. What is this doing? You're going to give me some function, and you're going to give me a list of values. I'm going to apply that function to each value in turn and give you back the list of results. So I can say def double of x, return 2 times x. Def increment of x, return x plus 1. Def truncate of x, if x less than 0, return 0. If x greater than 10, return 10. Else return x itself. Okay? Now, data is -3, 17, 2, 5, 0. So what was my first function called? It was double. Okay, let's print data, and then print apply to each of double and data. I'm saying I want you to take that function double, and I want you to do that to each element of that list in turn, and give me back the list of results. Let's see if it works. Python red.py. Yep. -6 is twice -3, 34, 4 by 2, 10 by 5, 0 by 0. Okay. And now, I could also say a print apply to each of increment and data. Print apply to each truncate and data. Yep. All right, -3 becomes -2, 0 becomes 1, 17 becomes 18, and when I truncate, 0, 10, 2, 5, 0. Say again?
Increment
adds 1.
adds 1?
Yep, so -3 becomes -2. I'm not doing this to the previous, okay?
Yeah.
But, you've jumped ahead of me. Now watch what I can do. Print, put them all together, right? I'm going to continue the line. I am going to apply to each truncate of apply to each increment of, back up here. Let me do it this way. Apply to each double of data. Yeah, thank you. I got excited. Okay, what have I done? Well, I doubled data, then I incremented them, and then I truncated the results. And that's what I get out. Okay, what I'm doing is saying, take that function and do it for each element of that. Okay, now take that result, do this to each element of the result from that, do this to each element of the result from that, and show me the final result. Okay, so again, what I've done is separate these things out. This captures the per element operation, the basic unit of truncate, increment, double. Right? This knows how to do it to each element of a collection. Now, if I write functions the way we were doing it 45 minutes ago, if I've got 5 basic operations and 3 different ways to apply them, I have to write 5 times 3 is 15 functions, right? I have to write an apply to each for double, and I have to write an apply to each for increment, and I have to write one for truncate. Okay? And if I've got different things like combine elements, filter elements, and so forth, it's a multiplicative problem. This many basic operations, this many different ways to apply them, A times B. Now I've turned that into a plus b. I write the primitive operations once. That knows how to work on a single value. And I write the thing that knows how to do that to a collection once, and then I just pick one from column A and one from column B and put them together. I've got a lot less code. A plus B is usually smaller than A times B. Okay? And that's why people do this. Apply to each, has some clever logic. Go through the list and apply the function to each value in turn and collect the results. There's a lot of ways that could go wrong. If I use this trick of passing functions as arguments to other functions, just as I did here when I'm saying calculate the average of f of x, that's the rule. Now you tell me what your f is and I know how to do this. If I apply that to programming, I've got a lot less code to write and debug. It also means that my program is a lot more flexible. If I want to add one more basic operation, I write it once. I don't have to come back and say, right, now I need another function that knows how to do that to a list of values, and another function that knows how to, and another function that knows how to, and so forth. I can mix and match these components to get the effect I want. There was a question.
Yeah, I was going to say, it might be because I'm not used to it, but it looks confusing to me. Because truncate, increment, double, and data, when I look at that, I don't know which one's a function and which one's a variable.
Yep.
Such. Would they not make sense to call them truncate function?
Absolutely.
Like
Absolutely.
Naming convention
Yes, absolutely. Absolutely. What I would probably do is I would put these in a library called something like filters. And I would refer to filters.truncate, filters.increment, and filters.double. And the name of the library would tell you, right, this is one of those functions. Yes, absolutely. There would be something in the names that indicated that's not a signal, that's a thing we do to signals. Right? Some languages actually force that. The syntax of the language says, for example, in Perl, right, they use things like $sign to mean this is a scalar variable, it's got one value, and an @ to mean this is an array. $Fred and @Fred are two different things. One is a single value, one is a collection, and then they've got other syntax to mean this is a function. And it's very clear from the syntax whether you're talking about a data value or a function. Okay? Python doesn't do that, but you can get the same effect. Some people will put _f, truncate f for function, increment f, double f, and so forth, right? Because somebody might look at double and say, does that mean double precision number, or does that mean double the value, or what is it, right? Absolutely, from a readability point of view, I wouldn't do it this way, right? I would have something else to help you figure out, that's my signal and I'm doing this. Please.
What if the function takes more than one argument?
Okay, it becomes a little bit more complicated. For example, if I want to truncate, but it takes a couple of extra parameters. Truncate doesn't just take one value, it takes a floor and a ceiling. Right? Okay, we'll take a look at how to do that after lunch. Again, the syntax becomes more complicated because the use case is more complicated. Right?
You think it would anyway make sense to do it that way?
Oh yeah, absolutely. Because I want to take A times B and turn it into A plus B. A little bit of complexity in my program, and I completely agree that having functions that work on other functions requires a little, it's one extra level of abstraction, which means one extra level of what the hell's going on here. But the payoff is huge. The payoff is enormous. You can reduce the volume of code you have to write and debug several-fold. So a little bit more complexity, a huge savings in how much code do I write, and how flexible is that code.